MiniMax H3 produces some of the most impressive open-source video currently available. But if you're running it locally, waiting 10 minutes or more for a single clip often kills the creative momentum. Look at how the model handles the physics here. It manages complex, overlapping motions, like the hair and fabric, without losing coherence. Achieving this level of detail is the goal, but the processing cost is high. We can reduce that cost. By linking 3 specific acceleration nodes, we can cut the total generation time by over 60%. To get these results, you need updated ComfyUI, the ComfyUI Manager extension, and INT8 MiniMax models. Reclaiming 6 minutes on every generation enables a rapid, iterative workflow. It allows you to test multiple seeds and prompts in the time it used to take for just one. To begin, start with a blank ComfyUI workspace. We need to install 3 specific extensions to optimize how the GPU handles the MiniMax transformer. First, open the ComfyUI Manager and search for the ComfyUI KJ Nodes package. This gives access to Sage Attention, replacing standard attention calculations with a more GPU-friendly method. Second, find and install the Sol Attention extension. This tool dynamically identifies which areas of your video need the most processing power. The third component is EasyCache, now a native node in ComfyUI. You just need to restart your software for the other extensions to activate. Using these specific updated tools helps prevent the out-of-memory errors that typically occur when generating local video on 8 or 12 GB cards. To build the chain, you have to disconnect the main MiniMax model from your downstream samplers. We are creating a pipeline that processes the model data before it hits the sampler. Connect the model output to the Sage Attention node. Route the Sage Attention output directly into the Sol Attention patch node. Pass that output into the EasyCache node. Finally, connect EasyCache back to your samplers to complete the circuit. Keep this exact order. Reversing these nodes or bypassing one will cause the cache to conflict, which usually leads to a generation failure. This sequence creates an optimized pipeline, streamlining the way your GPU handles the relationship between thousands of individual elements in every frame. With the nodes wired, we set the values. Let's start with the compilation parameters in Sage Attention. Set Allow Compile to True if you are working locally on your machine. The first generation runs slower while compiling, but the subsequent runs will be much faster. If you are using a cloud-based GPU, set compilation to False. Cloud resources often reset between sessions, meaning you would recompile the model every single time. In the Sol Attention node, set the tau variable to 1.2. This controls the acceleration strength by reducing computation on less important areas of the image. To protect quality, set the start percent to 0.2 and end percent to 0.9. This ensures the model fully calculates the beginning and end of the video, where motion is most sensitive. For EasyCache, set the reuse threshold to 0.3. This allows the model to reuse unchanged information between frames without redrawing static pixels from scratch. These specific parameters provide a mathematical balance. You gain significant speed without seeing a noticeable drop in the final video quality. Start your first generation. If you enabled compilation, the progress bar will move slowly at first. This is normal. Once that finishes, run the same prompt again. Now you're seeing the true, optimized speed of the chain. The 10-minute generation time has dropped to approximately 3 minutes and 34 seconds. Despite the speed increase, the motion remains physically consistent. The character's hands and the mechanical objects they're touching don't warp or artifact, matching the stability of the original model. This 3-node configuration applies to image-to-video and reference-to-video formats too, giving you the same speed advantage regardless of your input type. This customized pipeline unlocks high-end generation capabilities for everyday creators. It makes local, high-fidelity AI video a viable tool for rapid production.